Hello students, let us review thermometry of class 11. So what is heat? It makes a sensation of warm and it is a form of energy. The thermal energy which flows from one body to the other due to temperature difference is called heat. Suppose when there is a temperature difference, heat flows. When there is a pressure difference, air flows or water flows. When there is an elevation difference, water flows. Like that, when there is a temperature difference between two bodies, the heat flows. Heat is a form of energy. It always flows from higher temperature to lower temperature. See, certain is latent heat. Used to change the state from one state to other. Suppose from ice to water, the temperature is difference is not there. Both are at say 0 degrees and 0 degrees. Again, water to steam, 100 degrees, 100 degrees at one atmosphere. So even the same temperature, the change of state also needs some heat. So now what is a calorie has been defined as? Calorie is the amount of heat required to raise temperature of 1 gram of water through 1 degree centigrade. I want to raise 1 gram of water through 1 degree centigrade, the amount of heat required. So we are defining a unit of calorie. Suppose 1 kg of water, it is 1 kilocalorie. Since 1 gram, 1 degree centigrade, 1 calorie, 1 kg of water if I have raised to 1 degree centigrade, then it is 1 kilocalorie. So there is a conversion between heat and work. Joule is work and calorie is form of heat. This is form of energy. And conversion is 4.2 joules. This is SI unit. Joule is SI unit. Calorie is normal unit, but joule is SI unit. How the temperature is defined? Is defined as the degree of hotness of a body. Suppose pyrometry means study of high temperatures. Cryogenic, we have heard of cryogenic engines, study of very low temperatures. Normally we need this at some Finland where the temperatures are very low, minus 20 degrees centigrade like that. Even further, cryogenic is further down in terms of some 100 Kelvin in that range. So now you see there are centigrade scale. The ice to water point is divided into 100 points. And we have Kelvin scale. Again, ice to water point is 100, but ice starts at 273. We have Fahrenheit scale. The ice point starts at 32 Fahrenheit and the scale is divided by 180 numbers. We have a Romer scale, Roemer, so 80, the divisions are 80. And we have a Rankine scale. Starts at 492 and the division is 180 between ice point and steam point. Now, let us understand coefficient of linear expansion. The change in length per unit length at 0 degree centigrade. From 0 degree centigrade, the change in length per unit length is called coefficient of linear expansion. This is L alpha dt theta. The change in length is original length, alpha d theta is temperature difference. Similarly, it can be written as tension. Tension also Y is Young's modulus, area alpha d theta. Coefficient of superficial expansion. The change in area of the surface per unit area at 0 degree centigrade per degree of centigrade rise of temperature. So change in area is original area beta d theta dt. Dt is temperature difference. The same is the coefficient of cubical expansion. The change in the volume per unit volume at 0 degree centigrade per unit rise of temperature. Delta V is V gamma dt. It is observed that alpha is to beta is to gamma are in the ratio of 1 is to 2 is to 3. So coefficient of apparent expansion. Suppose if I heat liquid, the coefficient of apparent expansion is defined as apparent increase in volume when I per unit volume of the liquid. Here we don't consider container expansion. We are only considering water expansion, thermal liquid. So it's called apparent expansion. If I take container expansion also, further I have to add that container volume for this level. So that this is a real expansion of coefficient of real expansion. Sometimes you can have problems on both issues. So what is a triple point of water? Triple point is the SI unit of temperature. This is the standard unit of 273.16 Kelvin. The value at which pressure and temperature, water exists in 3 states is ice, water and steam. It exists a triple point. Pressure is around 0.06 atmosphere temperature. So it exists in 3 states. From this scale, all other scales are defined. What is specific heat is a capacity? The amount of heat required to raise the temperature of unit mass of material through 1 degree centigrade. So specific heat C is defined as Q, amount of heat required for unit mass for unit rise in temperature. Delta T is 1 degree centigrade. So if I take this Q here, mc delta T, this is the thermal capacity of a body. If I go for molar also, instead of mass, it is a molar, or unit molar. It is a molar capacity. Specific heat of molar heat capacity. So what is water equivalent of a body? Suppose I supply Q, and to raise the temperature, the amount of equivalent water required, say for the same Q to the same temperature, is water equivalent. Water equivalent of body is defined as the mass of water required, which gets heated to a certain range of temperature by the amount of heat required to raise the temperature of body to the same range. So for body, say 10 kg of body, I am raising to 10 degrees centigrade. Some Q is required. Same Q, to raise 10 degrees of water, how much water is required? That is water equivalent of body. So water equivalent of body is equal to M into C. Mass into C is the specific heat of the body. So what is specific latent heat of fusion? We know from ice to water, specific latent heat of fusion substance is defined as the amount of heat required to convert 1 gram of substance from solid to liquid. It is around 80 calories per gram or 80 kilocalories per kg. Similarly, vaporization for 1 gram of water to steam is a latent of vaporization for water. So it is around 540 calories per gram, 540 kilocalories per kg. Now we have two types of specific heat. As we have already seen, specific heat means raising unit mass of metal through 1 degree centigrade. But here it can be at constant volume or it can be at constant pressure. So specific heat at constant volume is defined as Cv, and constant pressure is defined as Cp. So the constant pressure is always more than constant volume because it has to do some work also. Constant pressure means it has to do some PdV work also. So Mayer's formula says for Cp minus Cv is equal to R, universal gas constant. For unit, this is called Mayer's, is a molar specific heat. What this is? Molar, we know Pv is equal to nRT, Cp minus Cv is integral Pdv, Pdv is nRT. If n I take 1, because Cp, Cv are molar specific heats, we take 1, R into T is 1 degree centigrade, so Cp minus Cv is equal to R. So Cp by Cv is defined as gamma, is a adiabatic expansion constant. Gamma is Cp by Cv. If impurities are there, their melting point will reduce and boiling point will increase. The gap between melting point and boiling point will rise if the impurities are there. What is sublimation? Suppose directly from solid to vapor, iodine will not come to liquid, it comes solid to vapor. There is a hoar frost from vapor to solid. Sometimes you see frost right directly from vapor, it forms ice cubes. Okay, this is a hoar frost. Let us take one temperature. There are two scales A and B. They have reading triple point. Scale A as 200 A, scale B as 350 A. So what is the relation between the TA and TB? See, for the same temperature, A is showing less, B is showing more. So their relation should be 200 is to 350, that is 4 is to 7. If you see otherwise, T 273.16 Kelvin is defined as 200 A in scale A. So that is in scale B, 350 A. So T in scale is TA into 273 by 200 by 350. So 200 into T is TA, 350 into T is 3B into 273. When I scale, so 4 is to 7 because TA for the same temperature is reading less number. Now, suppose I have two material, iron and copper. The length should remain 10 centimeter. The difference between length should remain 10 centimeter at all temperatures. What is the length of iron rod and the length of copper rod? That means what we want, L1 minus L2 is always 10 centimeters, means 0.1 meter. So alpha is given, alpha of copper and alpha of iron are given. So then L1 alpha 1 d theta is equal to L2 alpha 2 d theta, so that their expansions will remain same for the to maintain the difference of 10 centimeters. So when d theta theta gets got, L1 alpha 1 is equal to alpha L2 alpha 2. When I solve these two, I get L1 28.33 centimeters and L2, this is L2, is 18.33 centimeters. So the pendulum time. How we have defined time period of pendulum? 2 pi root L by G. So T is directly proportional to root L. So when I take differentiation, dt will proportional to half dl. Dt is proportional to half dl. So dt is half into t alpha d theta. The time period for the second pendulum is 2 seconds. 2 into then it will become dt is alpha d theta. Is it? There is a time 86,400 seconds. So into dt will get the change in time period. So the pendulum, if length is increasing, it takes more time. Takes half of the t alpha d theta more time. It takes the so that in that case what happens, for same second it will take more time. So in a day we lose time. Day will be live over, but time will not show that much. So otherwise, if the length is reduced, it will gain, it will move fast. The length is increased, it will move slow. Time clock will be slow, I have to readjust it. Let us see the bimetallic string. There are two metals. This is iron, this is copper. We know alpha of copper is more than iron. Here we have seen alpha of copper is 17 × 10⁻⁶ and iron is 11 × 10⁻⁶ per degree centigrade. So 11 and 17 is more. So if they are getting heated up in our thermostats, we use them in thermostats. If they are getting heated up, they bend like this. Automatically they bend towards iron side. Because iron expansion is less, copper expansion is more. Automatically they will trigger off a alarm to switch off, so the equipment will get switch off. Once it is switch off, again they become straight. So this is used in the principle of linear expansion is used in thermostats. Again, density also will get reduced at a temperature T, rho 0 into 1 minus gamma T. How this has come? Now, rho 0 10 minus 1 minus gamma T. See here, volume is V0 into 1 plus V0 gamma delta T. This is a cubical expansion. This is a V0 gamma delta T is the new volume. Suppose then rho 0 becomes what? M by V0. What is rho? M by V. When M by rho is equal to, when I substitute, M by rho is equal to M by rho, V is equal to M by rho, V0 is equal to M by rho 0 into 1 plus gamma d theta. When I substitute here, V0 will not be there because V0 has come outside. Okay. M by rho 0 into 1 plus gamma dt. This is when I bring it to this side. So rho will become rho 0 by 1 plus gamma dt. That means rho 0 into 1 minus gamma t. When you take rho 0 to upside 1 plus gamma t from the denominator to numerator, it becomes 1 minus gamma t. This is the same thing shown here. Rho at density t, rho at t is equal to rho 0 into 1 minus gamma t. These are all fluids except for water from 0 to 4 degrees. This is the anomalous expansion of here density increases. As the temperature increases, here density increases. From this onwards, again density reduces. So similarly, for all Pt minus P0 by P100 minus P0, we give a pressure scale for the same to read the temperature. Similarly, resistance RT minus R0 divided by R100 minus R0 will give resistance variation with respect to temperature. RT is equal to R0 into 1 plus alpha t plus beta t square, where alpha beta are constant. So these are various relations we can measure the temperatures in various parameters. What is thermoelectric motive force? It is a thermocouple. When two junctions of a thermocouple are kept at different temperatures, then EMF is produced. EMF is produced and current flows. This is called thermo EMF. Normally we use in our all modern temperature measurements. The inner side will be subject to the heat of the system. Then we get a voltage. This voltage is sent to control room to measure to give an indication of temperature. So the voltage developed is in terms of AT plus B T square. T is the temperature. These are two are constant. Suppose T at ET by E100 into 100 is the percentage of at temperature T. We have recorded E100 already. 100. Then once ET EMF is developed, we will know what is the temperature. So now what is a calorimeter? This is a calorimeter where we find a hot body is mixed with cold body, and the heat lost by hot body is equal to the heat gained by the cold body. So from which we find the calorific value of the material. This is a calorimeter. Is oxygen is supplied so that the sample can be burned fully. This is ignition wire to supply heat. Oxygen is supplied. The water is completely taken by this water. Then the steel bomb. This is steel bomb completely for burning this. Then we have water to take complete heat. So the heat transfer between this will give how much heat it has released. So we know the calorific value of the sample. This we have already discussed. Suppose a sphere of a diameter 10 centimeter and mass 800 grams float in liquid. As the temperature is raised, sphere just begins to sink at the temperature of 50 degrees centigrade. If the density of liquid is 1.6, find the coefficient of cubical expansion. What is happening? What is diameter is 10 centimeters and weight is 800 grams. So we know the sphere, mass by volume 800 by 4/3 pi r cube. So we get this is the rho of the sphere. I put everything in grams. So 1.528, this is 1.6 at 0 degrees. So as temperature rises, this becomes 1.528. Then the ball start sinking. So rho is equal to rho 0 into rho 0 divided by 1 plus gamma delta T. So when this goes to other side, 1.6, what is rho is? Ball 1.6 into 1.528 divided by 1 plus 50 gamma. So same formula I have separated. I have taken to this side. So I get gamma as 9.4 10 to the minus 4 degree centigrade. See, as the temperature rises, the gamma has reduced. This gamma has reduced. So 1.6, 1.528, here it is increased. 1 plus 50 delta T, gamma delta T. This has increased. It becomes 1.6. So gamma became 9.4 10 to the minus 4 degree per degree centigrade. Here note, the sphere density also reduces because its temperature also has risen. But that we are neglecting. You see another one. What are the values of temperature whose numerical value is same in centigrade and Fahrenheit, and numerical value is same in Kelvin and Fahrenheit? So how the conversion of centigrade to Fahrenheit? C is equal to F minus 32 into 5 by 9. So F is also C because numerically they are same. So C is equal to C minus 32 into 5 by 9. That comes minus 40. That means minus 40 degrees centigrade is equal to minus 40 degrees Fahrenheit. Similarly for K, how the K is defined as into Fahrenheit, F minus 30 into 5 by 9, this is degree centigrade plus 273. That is Kelvin. So once F is also K because both are numerically same. So K is equal to K minus 32 5 by 9 plus 273. Then the value comes to 574.25. So this is a Kelvin as well as Fahrenheit.